Hello. Good afternoon. Perfect. Good afternoon, everyone, and welcome to our CGFI Connect event, which we are organizing together with our friends at the Royal Meteorological Society. I'd like to do a pre-welcome before handing over to Alyssa for a more proper and sophisticated welcome than I've prepared. But just as in terms of introduction to ourselves and to the event today, so we are the UK Centre for Greening Finance and Investment. We're set up or funded by the UK government to help translate climate and environmental science and data into financial decision making. So our remit is very much on connecting the climate science community with various financial institution ecosystems. And today, our CGFI Connect event is very much, let's say, a core example of how we're trying to do this, bringing together different communities on the science side, on the industry side, as well as on the kind of data analytics provider side that can help operationalize some of these insights into actual decision making. Very much thank you for all showing up and coming here today. We have a really good mix of people, really good turnout. So thanks for taking the time on a Wednesday afternoon to come and see us at the Royal Institution. You will hear a lot more about the different things and science and topics that we're working on throughout the day. And I'll talk a bit more about things we're doing afterwards at the end of the event. But again, thanks so much. Thanks also for our speakers who've made time to come here today. And I'll now hand over to Alyssa Gilbert to welcome us properly to the Royal Institution. Thank you, Alyssa.
Thanks, Christoph. Welcome here to the Royal Institution. I am the Director of Climate Change Innovation at the Grantham Institute at Imperial College, and I run Undaunted, which is our climate change innovation program. We run that together with the Royal Institution. That's why you're here, and I spend some of my time here. And what we're trying to do is bring together the entire innovation journey, from connecting to the public and people who could be potential innovators to tackle the challenge of climate change, through to our connection with the academic community and creating new ideas, innovation, creation, and entrepreneurship, and then helping grow up and scale those businesses successfully to have impact. Our connection with CGFI is both through the Imperial College connection, the academic research part of it, but also importantly, part of the project is about stimulating new innovative climate businesses at the very earliest stages of connecting with the science, and then helping grow those startup businesses and help them scale up successfully. And this event today is a really important part of that story, bringing together the deep scientific and research capability that we have in many institutions, together with knowledgeable user communities and people in the business world to try and understand how we can better work together, and then perhaps help generate some of the seeds of ideas that can enter this innovation and entrepreneurship funnel. When we talk about entrepreneurship, we imagine often startups, and we support a lot of startups, but we're also really interested in intrapreneurship. And I know there are some people here representing larger businesses, very established in the insurance markets and in London's financial sectors. And we're equally interested in how to make innovation happen in those organizations and how we can combine our R&D efforts at the earliest stages, both within businesses and within the academic sectors, to then deliver successfully into this pipeline and make London and the UK the green financial centre that we think it can be, and also have that global impact that we urgently need to have. So I really welcome you here to one of our homes at the Royal Institution, and I hope that we have a fruitful and in a way mission-orientated discussion. So thanks for joining us here today. And I'll hand over to the panel, right? Jason. Okay. Okay, Liz, Professor Liz Bentley from the Royal Meteorological Society, who's co-organized this event. Pleasure to have you here.
Great, thank you. Right, I'm going to need a hand in loading my video if I can. So I'm Professor Liz Bentley. I'm Chief Exec at the Royal Meteorological Society, and we're obviously co-hosting this event. Delighted to see so many faces in the room, and obviously we've got some online presence as well here today. I've got 10 minutes. I was going to take you through our role within the engagement with the insurance sector, but I'm going to start with the work of the Royal Meteorological Society, because I'm guessing many of you in the room, even if you've heard of us, probably don't know the kind of breadth of activities that the Society does. So I've got a short video, which I'm going to play. It only runs for 1 minute.
So many conversations start with the weather. And and so many answers are yet to be found. But it's when you make a connection, a physical connection, a scientific connection, a connection of interest, that's when the world can change and doors can open. Weather doesn't discriminate, and neither do we. There's been no greater time to unite in our passion for understanding weather and climate, and shaping the future of our world for the benefit of science and humanity. We may be over 170 years old, but we are not standing still. Our journals showcase the latest advances whilst drawing on the past, and our members are some of the most forward-thinking people on the planet. We are an independent voice uniting communities. We connect students with mentors, climate scientists with ecologists, communicators with researchers, and photographers with meteorologists, and we connect everyone with the weather. Whether you are working in the world of weather and climate, or just have a curiosity about the world around you, we are here for you. Join us in empowering future generations. Join us to learn something new. Join us on your career journey. Join us in our passion. Join us.
Great. Is it a separate PowerPoint? Sorry.
Good evening, ladies and gentlemen. Welcome to the East Midlands Centre of the Royal Meteorological Society.
That was a bonus video.
Thank you. So that video just gives you, I think, a brief overview of some of the work of the Society, but I just wanted to spend a few minutes really taking you through the breadth of the work of the Society. So we're the learned and professional body for weather and climate in the UK. We're a small charity. I've only got 17 employees that work for us, but we're fortunate that we can tap into a wealth of volunteers who support the work and support us in our strategic objectives. So we've got over 400 volunteers who help us to deliver on our activities. As a membership organisation, we have about 3,000, just over 3,000 members. We've got quite a broad church of people who engage with us, so academics and students, through professional, operational meteorologists, consultants, even through to amateur meteorologists, so people who don't work in meteorology but have a real passion for weather and climate. And we're very fortunate to have a topic, I think, that engages with lots of people. We have members who are in academia working in insurance, and also those in the insurance sector as well, so it cuts across this sector quite nicely. We don't do any weather forecasting or any research into meteorology. We kind of facilitate all the things that support the people who work in operational meteorology or work in universities and in academia. So we have our scientific publishing arm, and you can see there are 8 journals shown on the left-hand side of this slide. It's our journal portfolio. We do special issues relating to topics of interest to both the academic community, but also through into applications and into the sectors such as the insurance sector. We have an academic book series, and we also have a more public engaging book. So the example here is the A to Z of weather that we launched in recent years, again, just to educate a kind of wider audience into weather and climate. We host over about 60 events each year, and I've put a few examples up here that are probably relevant to this audience. So back in February, we ran an event to look at papers that would be of interest for the insurance sector. This was one of the first activities of our insurance SIG, which I want to go into in more detail in this presentation. We run a series of masterclasses jointly with the University of Reading. We have a kind of spring and an autumn series, and the aim of that is to just bring operational meteorologists up to date with the latest thinking in the science that they can pull through into operations. And we also have lots of courses that are online courses of general interest. So the top right is our online Come Rain or Shine on the FutureLearn platform, an open university course for anybody who's interested in weather and climate can go and learn a bit more. Underneath that, we have MetLink. So this is our education portal. And as a charity, that's one of our main charitable activities. So we get involved in curriculum reviews and specifications for bringing weather and climate into the classroom at all different levels. We also get involved in resources to deliver on those specifications. We work with examining bodies to make sure that the questions and the model answers are fit for purpose. And we also do teacher training as well. So this is a really big part of our charitable activity. And MetLink is a free resource. There's lots of educational resources on there. If any of you get involved with STEM activities, I'd point you to there to go and find some useful resources. We do a lot of public engagement. So we have a Weather Photographer of the Year competition that we're about to launch next week. And that obviously has an opportunity to engage with a much wider audience on weather and climate. And we get involved with a lot of activities. We've got observer status with the IPCC and also at the COPs. So we're quite fortunate to be able to kind of see behind the scenes and then demystify these activities, both with our members, but also wider audiences as well. And the example here was COP26 that we were at. We also are the only body in the UK that oversees professional accreditation in meteorology. So, for example, here's the chartered meteorologist. For those working in the meteorological sector, you can work towards registered or chartered meteorology. And then there's just a final example here. We do have a UK focus, but we also do a lot of work internationally, one of the largest meteorological societies internationally. And this was an example of something we did just ahead of COP27 in Egypt to pull together training material relevant to the African nations. But the main focus, I think, for today is to talk about a recent activity. And this is our 3 special interest groups that we launched last year. So we introduced 3 fellowships and brought in 3 individuals. You can see them here. Matt on the left, who looks after our energy sector special interest group. On the right, we've got Daniel, who's looking after our youth and early careers. And in the middle, and the focus for today, is the insurance sector. So Hannah, who's sat at the front here, is our science engagement fellow overseeing our insurance sector work. And that's really the focus of the rest of my few slides, really to take you through the activities that we've been doing since Hannah took up that role last June. So there's a lot of things that we've been doing. So one of the first things that Hannah did was to actually pull together a survey to reach out to the insurance sector to understand, I guess, the breadth of backgrounds of people working in that sector and the areas that we needed to kind of pull together onto that special interest group to take forward the activities. So a couple of things came from the survey was that I think we needed to broaden the membership on the SIG, on the special interest group, to make sure we covered all the different kind of weather perils that are important to the insurance sector. So that was certainly one of the first actions. And the second bullet point under that is around, I guess, bringing out the important papers that are published in our journals, particularly the Royal Meteorological Society's journals, that are pertinent to the insurance sector. And that led to an event that happened in February this year. Again, you'll see that further down on the list. So on the 9th of February, we hosted a virtual meeting, really focusing on the insurance sector, looking at the papers that were relevant to you, so synthesizing those out to take that kind of work away from you to deliver that. And you can see a URL link here, so if you're interested in that, if you didn't manage to get to that meeting, then go onto our events page. We've got a recording of that, so you can go and listen back to that. So the survey then led to further development of the special interest group, and we've now currently got 8 academic specialists, 7 from universities, 1 from the UK Met Office, and 10 members, a diverse range of members from the insurance community. Another activity was to develop the special interest group member career profiles. So again, looking at people on the SIG and working within the sector to look at the kind of career profiles of those individuals. And then the event, so I mentioned the February one, the event obviously here today. And I think today's meeting for me is quite particularly of interest because we're pulling together a roundtable event, which will happen in the autumn. And I think we're trying to kind of work out what we want to get from that roundtable. So we've already started some discussions over the last few weeks, and I think today's meeting will help with that. But for me, I think that roundtable meeting is going to be about how we bridge any gaps between academia and the sector. And again, we're discussing that today. So I think today's meeting will certainly tease where that roundtable meeting goes. We're also looking at partnership activities. I know there's been some work in recent weeks to look at how we can actually work more closely in bridging that gap, so a physical activity rather than just an event. And I think having discussions with people just before this meeting, that seems to be progressing really well as well. And then finally, there are the special interest group meetings themselves, and Hannah's been leading on those and chairing those and bringing people together from the sector to review things like the survey and the activities that we're doing. So my next slide really just looks at one of the other results of the survey. So we talked about, the breadth of weather perils within the sector and the need to synthesize out articles published in our journals. But here are a list of requests that came from the insurance sector, and the ones you could see highlighted in blue are areas that Hannah's been moving forward over the last kind of 9 months or so. And I guess we'll start to look at some of the other points as we go forward in time. So really, just to finish, is we have a newsletter. So if you're not part of the SIG, but you're interested in finding out what the Special Interest Group does and the activities that I've just mentioned and ongoing activities, you can join up to this newsletter. The URL is on the right-hand side, highlighted in yellow. It's quite simple form, as you can see. So yeah, I'd just encourage you to do that if you want to find out more. That's it from me.
Thank you. Got my water as well. Don't know if anybody else is suffering with hay fever, but hopefully my voice will hold out. Talking of surveys, I'm hoping everybody has received a link and an invitation to take part in a survey that focuses on uncertainty, that focuses on high impact events. I'm going to ask for a show of hands who has seen the link so far. Okay, quite a few. We'll put another indicator on the screen throughout the meeting. I'm not going to ask who's filled it in or not. That wouldn't be fair. It'll be open until the end of the week. Today, I thought what I would talk about are some of the areas of climate science where we've seen recent developments. Those areas typically are still moving forward. They're exciting things to come. It's a very personal view. Other climate scientists in the audience might have picked a different set, and hopefully that will come out in the questions. I also have a couple of examples of where what I would think of as more academic climate science is working more closely with colleagues in the insurance sector. I think we're only really scratching the surface on this, and events like today are really, really helpful in making those links a lot stronger. My affiliations, just from the slide, so most of the week I'm working at the UK Met Office. My focus there is on trying to make the climate science we produce as useful and as usable as possible. And what that means is practically leading on topics such as the UK climate projections. I also work part-time at the University of Leeds, and through that affiliation, a part of CGFI. So let's start with observations. What I'm going to do is I'm going to work forward through time. So we'll do observations, then near future, then distant future. We need observations. The observations are telling us what's happening in the real world. We need observations because they help us construct models. We need observations because they help us evaluate those models and understand how they're performing and understand the difference between the model world and the real world. I've got some examples of observational data sets on the slide. So at the left-hand side, this is a set of UK data, NCIC data. It's updated regularly. It's available on a range of resolutions from around 1 kilometre to Corsa levels, or you can download the station data. I'm also showing at the bottom something called the climate dashboard. And this is an attempt to make more of the data more accessible. This particular plot is for sea level. There's a whole range of climate-related variables that go from greenhouse gas concentrations through climate response. You can also click through to download the data sets. But the plot above that kind of illustrates one of the issues with observations. We don't have complete coverage. This is showing stations that feed into a particular data set when we want to look at daily maximum temperature. And you can see there are big gaps. You can see where the gaps are very varied over the world. If we were to look over time, we would also see those gaps changing over time. So it's an incomplete record spatially. Also, we've experienced climate change to date. We're now living in a world that's around 1.1, 1.2 degrees above pre-industrial levels. So climate change has already happened. The climate is not stationary. And if we want a period of present-day climate to explore, for instance, to look at long return period events, actually the observational record is quite short. But we still need it. Some of the developments that really stand out for me are the use of data recovery. These are unearthing extra observations. They might be locked away in libraries, in physical books like these. And through community efforts, such as the one organized by Ed Hawkins, we're being able to digitize more and more of that data that's locked away. The other really exciting area is the idea of opportunistic observations. What do I mean by this? So there was a project I had the pleasure of seeing up close last year. That was using CCTV cameras that happened to be pointing in a direction that looked out to sea. Might not be what the camera was set up for, but nevertheless you could see the sea in the background. And using fairly clever machine learning approaches, it was possible to take the output from those and construct a data set, and this was just at 1 or 2 points as a demonstration, of the sea surface state and information about the waves. As we move forward towards autonomous vehicles, the wealth of data that will come from that source is immense. We'll have information on temperature, rainfall, visibility, possibly around perils like hail, for instance. And it opens up new opportunities to fill in the data record. Having said that, if we want to look at longer return periods, we can still make use of, and we will still need, synthetic views of the present day periods, synthetic observations. And there are many ways to do this. Some of them purely statistical. Some of them, for instance, combining statistics with models of particular parts of the system, like tropical cyclones. Others, and the one I'm showing here that was originally developed at the Met Office, is taking a byproduct of the historic simulations that are part of decadal forecasting and using those as pseudo-observations, the so-called unseen method. This particular result that I've included as an example, this is showing wind speed, and this was from a study led by Gillian Kay that looked at wind droughts. And in this plot, the black dots are from reanalysis, and we'll treat that as a proxy for the observations at the moment. And there aren't actually that many of them. Each dot represents 1 week. If we look at the grey and blue dots, those are from the synthetic data set. Those are from Unseen, produced as part of the Depressis system. And in this case, we were looking at the low wind speed events. And you can see, well, firstly, there are many more blue points than there are black points. We're able to characterize that tail of the distribution more completely. There are also some blue points that are beyond the range of the black point. So there are events that we've not actually seen in the real climate that we can explore with approaches like this. So I think it's really exciting. I definitely recommend the paper by Vicky Thompson that I'm showing at the left. But there's always a but with using any data set, using any model. We have to keep asking ourselves, are the data physically credible? And there's starting to be a body of literature that is exploring the physical credibility of studies such as this. Sometimes they use causal networks and storyline approaches. Sometimes they use more statistically based approaches. The example I'm showing here at the bottom, this has a combined statistical and dynamic reasoning approach. We also need to ask, do the data sets span the full range of outcomes? They may be broader than the observations, but they may still be too narrow. And we need to think about what fraction of the uncertainty we're capturing. We also I think this is an area where we can work together with colleagues in academia and in the insurance sector. We need to compare approaches. We need to compare approaches such as unseen with those coming from more statistical or combined statistical and modelling approaches. I'm showing on the left-hand side part of the process we go through with unseen in terms of comparing with the observations. So from unseen, we can build up distributions, for instance, of monthly rainfall and look at statistics of that, including the mean, standard deviation, skewness, etc. And at least check that the observations are within those distributions. I would argue that's a minimum, and what we really need to do is understand the physical processes. Now let's move forward in time. So now we're looking at the near future, thinking a few months ahead to a few years ahead. So this is interesting from a scientific perspective, in that we're transitioning from an initial value problem, so the information locked up in the initial state of the climate, to a boundary problem. So here, the information on predictability is coming from the external forcing. And this period of a year out to 10 years is where we sort of transition between the two. So as we try to understand skill, we need to realize it comes from both of those sources. I've just shown along the bottom really some of the places the predictability comes from in these decadal forecasts. That includes slower evolving parts of the system, such as sea surface temperatures, but it also includes natural modes of variability, like the ENSO. There's also an impact from external forcings, including natural forcings, solar. We have an indication of what that will do, but also thinking about the effects of volcanic eruptions when they happen. And then as we progress further into the future, the importance of the anthropogenic scenario becomes more important. Data from decadal forecasts is now readily available. These are produced operationally, but they're not being used as regularly for decisions as perhaps they might be. We need to understand that. But we can certainly go and download these from the WMO site that I mentioned here. There have been some really interesting examples of trying to show how the skill on this decadal timescale can be used for practical decision making. And this flyer here is from a Copernicus project, C3S. And in this case, there was an approach of using the decadal forecast to look at decision making in the agriculture sector, the energy sector, and also the finance sector, focusing on insurance. Willis Tower, Watson were the insurance link, working with the academic partners. This felt like a sort of a toe in the water almost. There's a new EU project that I'm quite heavily involved in called Aspect that we've just started up in January. And what we're going to do here is, one, we're going to try to improve decadal forecasts, but also we're going to try and get better at merging the information from this 1 to 10 year timescale with longer term timescales out to 30 years. But we're going to put users at the center of this. So we have a number of super users. One of those is from the finance sector. And there's also scope for people in this room to get involved. Go to the website and we can bring you into the project and see what we can learn together. Now I'm going to move on to the longer time scale. And as we get to the longer time scale, now we have to start taking account of the scenario uncertainty. It's also an area where many of us might want to start thinking about transition risk as well. But today I'm going to focus on the physical risk. The pathways on the left-hand side are a set that was produced as part of the last IPCC process. There are more than 1,000 lines in that plot on the left-hand side. They're not predictions. Each one represents an internally consistent view of the future produced with an integrated assessment model. And they differ in terms of assumptions around population, wealth, trade, technology, and also policy. So behind each line is a storyline, but we don't typically try to put a probability on those. I've color-coded the green ones. Those are the ones that keep the median temperature response below 1.5 degrees at the end of the 21st century. And you can see very rapid emission reductions in that particular scenario set. If you're wondering what these stars are at the right-hand side, these are to illustrate, firstly, if we take current policies, so these are proper policies that have a grounding in law within different countries around the world. We add them up and look at the median warming response. It takes us to this range between about 2.3 and 2.9 degrees at the end of the century, so is not on course for a 1.5 degree future. If we take the net zero announcements, so often these literally are just announcements. They don't actually have a plan of how to deliver in some cases. In the UK, we do, but that's not the same in all of the cases. But if we add those up, then work, for instance, by Meinshauser et al. Shows that can take us towards just under 2 degrees. But we also can't rule out where the red star is. But to get there, you would need to backtrack on current policies. It's certainly plausible to do that. And I think it's quite interesting to start to think about which of these might be more likely. But this is global average future. Nobody lives in the global average. What we want to do is get local information. And this is where we bring in our general circulation models again. And I thought I'd pick 3 items around these models that I think are particular developments. So the first one is we're now getting to the point where we're seeing relatively small number of very high resolution global model simulations. The plot on the left-hand side, I highlighted with a circle the change in precipitation over the UK. And the bottom right, that comes from a model that is coarse in both the atmosphere and in the ocean. I think the atmosphere is around 250 kilometers, the ocean is around 50 kilometer resolution. As you progress in terms of finer atmospheric resolution, so going from right to left, and finer ocean resolution, going up the page, you get to a point where the model is behaving physically differently. Now, in this case, I think we've got down to around 50 kilometers in the atmosphere and 8 kilometers in the ocean. And it leads to a different positioning of the Gulf Stream. In turn, it leads to a different air-sea heat flux, effect on baroclinicity, and effect on the rainfall over the UK. But we need to really investigate that with larger ensembles. On the right-hand side, I'm thinking about more localized models. So in this case, we've had weather forecast models that run at a couple of kilometers for some time, but we only run a few days. What we're able to do now with convective permitting models is run these for several decades and look at the climate statistics in the future. Now, this has the advantage that by better representing processes such as atmospheric convection and also how the atmosphere interacts with the topography, we're better able to simulate extremes of temperature and rainfall in many cases. We can also give credible sub-hourly information. And the particular model I'm showing also has a different urban treatment, which we think is more credible. So it lets us get at local extremes. We've just released an update to the UKCP dataset that contains additional convective permitting model data. And my last one, I was struggling to narrow it down to 3. But my last one is about this idea of, as a community, moving from one model, one vote, to saying, well, not all models behave the same. Not all models necessarily have the same level of physical credibility. And increasingly, we're seeing approaches to either filter or constrain these models. It might be using performance in the present day, historical performance. It might involve looking at particular physical processes. And you can see from these two plots, they're based on CMIP6 data, and they're showing different attempts, these are the different colors, to constrain the CMIP6 ensemble. And in this case in particular, it's wiping out some of the very warm variants of the model. We've also done some work in EUCP to intercompare different constraining methods. That turns out to be quite difficult to do because there are very few studies out there that actually control to give you a like-for-like comparison. But using those intercomparisons, you can start to explore how the different constraining methods work and whether they're giving a degree of over or under confidence. We do need to be cautious, and there are methodological questions. Do we use a global constraint or a regional constraint if we're looking locally? Do the same constraints work with different generations of models? And can we actually understand the physical basis of the constraints? Because if we can't, then our confidence in those should be a lot lower. To finish up, I wanted to move on to two very quick examples of how academic climate science and insurance are working together. The first one is led by a colleague of mine, Laura Dawkins. And I wanted to show this example because what we've done here is take the technique of catastrophe modeling, taken an open source version of a particular model, and started using that to think about climate risk and climate adaptation. And in the examples that Laura has been running, we've been looking at an impact on the number of days that might be lost in terms of working because of high temperature. We've also worked with Department for Education to look at number of days schools might have to close. And this having access to an additional tool set's proved to be incredibly useful. On the right-hand side, this is an approach that Francesca was very heavily involved in, and it builds on her methodology to understand the sensitivities to those risk calculations. And I think these techniques we can use in both academic climate science and insurance. And then my final example is one from a project led by Len Shaffrey and Paul Bates, one of the flagships from CGFI. And this has looked at the correlation between variables, in particular precipitation and wind speed. And Hannah pointed me towards this really useful visualizer where you can explore the data set. So you can put in the correlation length on the right-hand side and pick appropriate variables and really understand how that is evolving over different parts of Europe. I put the URL so you can explore that yourself. So to end, how can we work better together? Firstly, I think we can do more of this sharing of tools. It constantly amazes me when I sit down with people from the insurance and finance sector, people like Claire, for instance, and learn about the approaches they're using. So I think we've got a lot to learn from the insurance sector. I hope we've also got things that we can provide to the insurance sector. I think we also need to find a way of providing quantitative comparisons of data sets. That's both between the models, the different models used in the insurance sector, and those models used in academic research. And we need to find a safe way of doing that, respecting the IP of different groups. I think there's scope for us to explore co-designing and running stress tests, including thinking about high impact, low likelihood scenarios and events. If I'd had a fourth item in the exciting areas, that's the one I would have picked, but I didn't include it because I can see various people in the room who I know will mention it in the panel discussion, and I know I'd get carried away if we started. But I think that area of stress testing is one we can really work together on. One of the areas with my Met Office hat on that would be incredibly useful is understanding what the insurance sector needs so that we can adjust the underpinning science, the model development and the observational data set development. And it would be very good to think about quality standards and how we push up the quality of our science. Finally, I think there are opportunities, and this kind of relates to, I think, Liz, where you were talking about some of the initiatives already in place or growing around joint training and skill development. And for the insurance sector, I think there's also the need to explore some of the wider roles of insurance in mitigation and adaptation. For instance, the emissions that come from either your industry or your investments, but also the role of adaptation, in insurance in adaptation, and what that means for promoting adaptation. That's it. Thank you very much.
Are there any questions for our two speakers before we head into the panel? You were both so clear. They're all speechless. So, handing straight over back to you, Jason.
Okay. So now we've got a panel. We've got 3 panel members. So if I could invite the panel to join me up here. Great. So we're going to start with a couple of minutes for each person to.
Jason, you might need a microphone.
Is that on? Is that working okay? Okay, so we're going to start the panel with an introduction to our 3 members. I think we've got enough time for 1, 2, 3 minutes to really say who you are, who you work for, and what your role is. What do you do? Should we start at this end with Claire?
All right. I'm Claire Burke. I am Director of Science at ClimateX. Academically, my background was in detection and attribution of climate change, so can we say whether or not this weather event was a result of climate change? I now lead the science team at ClimateX. We are interested in sort of the physical risk and impacts of climate change at present and in the future. Slightly different from the sort of CAT modelling approach in that we're not ensuring and looking at translating historical distributions into present day risk. We're looking at the climate signal now and in the future. We largely engage with finance and banking as a result of the recent regulation in that sector, but we also talk to insurers as well. A lot of the methods that we use are quite common a lot in the CAT modelling sector, but we have bits and pieces that are more broadly inspired by the academic community and climate science.
Excellent. Caroline?
Thanks very much, Claire. And good afternoon, everyone. Thanks for the invitation to speak today. So my name is Caroline McMullan, and I work for Verisk, in particular in the Extreme Event Solutions kind of department. So some of you in the audience may be familiar with this name if you work in insurance, perhaps some of you less so. It was a rebranding. We were formerly known as AIR Worldwide. So we are a catastrophe model vendor, and software solutions. So we have, around the world, global models for atmospheric, geophysical-based perils and sort of software solutions that allow the insurance sector to use these models to understand sort of the risk, sort of both from a hazard but also from a financial perspective for the risks that they write. So I, in particular, I head up a research team based in London. We're a small team in London. As a company, we're headquartered in Boston. And really my team, we're a bit of I call it a hybrid team. We're a research support team, as it were. So we work with our clients in the insurance sector to understand the models. How are they built? What are the assumptions that go in? Where, how appropriate are they for their exposures? How best to capture that risk? And if need be, developing their own views of risks to suit their own portfolios and their claims experience.
Excellent. Thank you. Adrian?
Hi, I'm Adrian Champion from Aon. We are a reinsurance broker. I sit in the catastrophe research and climate analytics team. My role is climate research lead for UK and EMEA and co-chair of the Aon Research Forum. So what we do is we work with our clients to help them understand what their risks are, essentially, by sort of what are the strengths and weaknesses of each of the CAT models, working closely with the CAT modeling companies as well to discuss what we think of their model and sort of work with them on that. And picking up on what Caroline said as well, helping our clients develop their own bespoke view of risk as well.
Excellent, thank you. We've got some pre-prepared questions, but I think the exciting bit comes when we get the questions from the audience. We never know what's going to come out. I'll start with one of the questions I've got already, give you time to start to think, but then I'll come to the audience periodically to feed in questions. So the more you've got, the better, the more challenging the question, the better as well. So this is a question to all of you. In this case, what are the main ways the insurance sector is using weather and climate data? And what do you think are the most important properties of weather and climate data that makes them usable? Should we start this time at this end?
So for us, we use a lot of climate and weather data simply to benchmark the CAT models. Obviously, CAT models are meant to represent the current climate, meant to represent the current risk, and really we use the data to be able to benchmark that view, but also importantly to challenge that view as well, because it's they are stochastic event sets. They are meant to represent the uncertainty. So we use the observation data really to do that. And pass on to Caroline.
Thanks, Adrian. And I appreciate we've got a bit of a varied audience here right now. So I think we're made up of academics, perhaps some are familiar with the insurance sector and catastrophe models, but some less so. So maybe I'll just, if it's okay, I'll just take a minute to actually explain how, as a catastrophe vendor, we actually use some of these data sources in building our catastrophe models. So first, I think there's the catastrophe model. Everyone's probably heard of that. We have hazard, vulnerability, as of exposure, and risk metrics that come out of that. So for this audience, probably a lot of the data from the weather and the climate is feeding into our hazard modules. So historically, there have been more statistically based kind of techniques. So, looking at distributions of, say, tropical cyclone parameters from historical records, using those distributions to sample and build up, permutations of what could are new storms that could potentially happen in the future. There are, over the years, as we've progressed and worked on sort of different perils, there are some perils that just don't lend themselves to those kind of statistical methods. We have to go sort of more deep into the physics of it, perhaps using sort of numerical weather prediction models, reanalysis data, to actually start to sort of simulate and then be able to perturb some of the output of that to generate our new new simulated events in the future. I think, going forward, this is an area where we're going to see this coming in a lot more. We're going to be moving perhaps away from statistical methods, more into sort of deep physics-based kind of methods for generating sort of correlated atmospheric perils around the world. And, data, climate and weather data is a very important part of that, as is deep learning. So using sort of AI to sort of know and when we can correct biases in some of these models, using it to our advantage to sort of help and downscale to the resolution that's appropriate for CAT models. There's often a mismatch there between the data that's coming out and the resolution that's coming out of the models and what we need to sort of, what is essentially trying to resolve, hazard and risk at a location level, because that's ultimately the kind of resolution that the insurance portfolios are at. So that's kind of in terms of a stochastic model that you might hear of. I also wanted to mention sort of event response. So the insurance sector as well, they'll use our CAT models sort of, in their day-to-day when they're thinking about pricing insurance, when they're thinking about purchasing reinsurance, how much do they need, what's the sort of right layers, etc. They can use those almost in their day-to-day. But when, a Hurricane Ian is looming down on you, or a Hurricane Irma, 2017, you as a team in the insurance industry, in the CAT modeling teams, you have to get into action. You have to sort of know you'll be getting questions from above, how much is this going to cost us? Do we need to start mobilizing claims adjusters to be able to be in the right place? Where do we need them, right? So event response is actually also an incredibly important part in the insurance industry. And there we'll be perhaps leveraging a whole suite of different sort of weather and climate data sets, not only from a vendor perspective to understand the event, to look in our catalog, have we got what we call similar stochastic events that have already been run by the insurance sector, so they can very quickly just look up what their potential loss would be. You can do that in a matter of hours once we've released those events. But they're an approximation. Every kind of real-time event is slightly different, and we're never going to expect to see the exact same event in our catalogs. So we'd also be working as a vendor in sort of as real-time or as quickly as humanly possible to simulate this event with the actual parameters. So we're taking those sorts of data sources and simulating that event. So maybe 3 days to a week after the event, people have a new scenario that they can run against. But we need to validate as well. So as much as our, the likes of Adrian and many of the sort of faces I see in the audience here, you will be questioning all those assumptions that go either for a stochastic catalog and our real-time events. So using those data sources to validate our assumptions and hold us to our models, really.
I'm just going to ask you a follow-up before we move on. I think one of the really interesting things I was thinking about recently was the different timescales that are interesting to the insurance sector. And I think you've started very much with the now, or now plus a few hours or a couple of days, really unpicking forensically what's happening. There's the obvious timescales of a year or so ahead, but talk me through the timescales of interest as you get out to a year and then go forward, and the different decision making you're thinking of on that timescale.
Well, that's true. I mean, I think as a vendor, most of our models are accommodated for looking at what was the potential risk for the next year. Most insurance policies, reinsurance policies, they last 1 year. There are some catastrophe bonds, so in the insurance-linked market, they're a little bit longer, maybe 3 years. So that's of an interest. But this is all again around that current day risk. So as I'm sure many of you be familiar in the audience, looking ahead at future horizons, whether it be 5 to 10 years, whether it be sort of 20 years, thinking about I suppose there are different business cases for looking at different time horizons. What is whether you're responding to a regulatory stress test, you might have a time horizon of 2030, 2050, for example. But internally, maybe actually your strategy internally as a company is more on the 5 to 10 years. But ultimately, I think there is a wider range. I would probably say, 5 to 30 years is probably what we're hearing as the most important kind of time range. But of course, we probably can't negate the longer timescales as well.
Thank you. Claire?
So to sort of complement the offering that the cat modelling industry has at the moment, and that the insurance sector uses, at ClimateX we're very much focused on the physical aspect of climate change and using physically based models. As the world is changing, and we had a great overview there, thank you. The actual risk that you have today may not be that well represented by stochastic event sets that are based on historical weather. So we're looking to complement this by using outputs from climate models. And these are purely physically driven, and they can produce unprecedented weather events. So hopefully this can help to complement the kind of things you might expect. And then looking even further into the future, 5 and 10 years, how that might change. Sort of bringing in the banking and finance sector as well. It's what that sector chooses to invest in and then chooses to insure as well, which will impact this industry. When it comes to data being useful, the kind of challenge that I have for the academic community is around model resolution. A better resolution is always better. More granular is always better for us, and obviously that is a challenge when it comes to climate modeling and simulations. And also climate change scenarios. The sector itself is using what is available, and those are RCPs and SSPs. And they were designed with a view inwards to the academic community rather than outwards, SSPs being more sort of real-world applicable than RCPs. We are very much tied to those, but they're not always the most useful thing to know for the industrial sector, especially for banking, finance, and insurance. Yeah, I'll leave it there.
That last point's really interesting, because the process to think about the scenarios for the next IPCC assessment has kind of just started up. And we had quite an interesting debate at the last telecall on this, of how broad the scenarios should be, how useful should they be beyond the mitigation question. So it'd be good to explore in a bit more detail offline, I think, some of those. I'm going to see if we've got a question now from anywhere in the room. Let's see how many hands in total. We've got 2 over there. So if we start in the second row first.
Thank you. So I've been moving around in my career, various places. I'm always very worried when the production of climate change information migrates from institutes that's got a lot of tradition of doing it. So I guess I'm asking the question in terms of what you're talking about, Claire, running your own dynamical models, knowing how long time it takes to set them up and test them. Are you going to add these runs to like Codex or something like that, so they can be evaluated and incorporated, so you can actually assess the quality of these runs? Because it's quite a lot of work to setting these systems up.
I'm going to suggest we actually get a view from everybody on this one, because I think there are several different angles to it. Who should we start with this time? Adrian, do you want to start? And then we'll move along.
Yes, I mean, as a broker who licenses quite a few of these models, obviously transparency and the ability to validate these models is absolutely critical for us, because our clients need to defend their view when they go to the regulator, when they go to the reinsurer, they need to defend their view of risk. That transparency is absolutely key. When we're talking about climate change, then obviously there are multiple elements to the climate change, not just the hazard, but the exposure vulnerability. We've got to understand the full uncertainty side of it. And a lot of the work that we do within the team I'm in is obviously validating independently the models Caroline and the other vendor modeling companies do. And we use the Cordex data, we use as much data as we can that is independent, that has been peer reviewed, has been that stress tested. So as a broker, the more transparent, the more that it's been peer reviewed, the more that we can see the strengths and limitations from that peer review, then yeah, we're always going to sort of be supportive of that.
Thanks. No, and this is a really good point, and I think actually this is something that I not sit here and say we need local domain expertise. We need the input from academia to tell us how to set up these models, which are the better, where are the biases, which to put more weight to, and so perhaps we are ingesting almost the output, but using of climate models, but sort of using it in a way where we're sort of downscaling and bias correcting to our needs. So I don't think we're not sort of setting up these models and simulations ourselves. We are using the output. We are, I guess, 4 or 5 years into a project where our aim, I don't mind sort of saying, is a very ambitious aim of one climate model for all sort of atmospheric perils around the world. And this has really been set up, with academia. So we have a number, 3 different kind of academic institutions around the world that have been helping us with this process as well. But absolutely, whether it comes for climate models or just even data sets as well, we have a sort of centralized team, whether it be a tropical cyclone team or a flood team or a wildfire team. And they will go around the world in turn, sort of building models for their respective sort of regions. But of course, that domain expertise of like what is the best data sets here in this specific region, whether it's Taiwan, whether it's the Philippines, whether it's Australia, talking to academia, that's an incredibly important part of the development. Knowing which have biases, which have got time gaps in, where there's been maybe instrumental changes, and we have to sort of cleanse sort of some of those time series data. That's where I think the academia can bring some expertise on that local domain. We also go through sort of peer review when we're developing our models. We reach out and we have, whether it be academics or sort of consultants, to actually look at what we've done and sort of give some comments on that. And that's, often, it helps certainly on the hazard data, but it's around the vulnerability data as well, which, I think just while we're mentioning it, it's incredibly important because, that local domain expertise and knowing what the practices are, how they're adhered to, that's a very important point.
So I make use of a lot of CMIP5, CMIP6 models, and the UKCP2 climatic convective model is very, very nice. I have a lot of sympathy for how long it takes to set up and run these models. I used to do that at the Met Office, and the amount of compute required. So we use almost entirely externally provided, publicly available climate models. What I would kind of like to see is more of a partnership when it comes to deciding what we do next in terms of running and setting up these models, where we set our priorities. Industry has a lot to bring in terms of what this is used for, but also in terms of funding. To say, let's have something that is both scientifically interesting for the academic community and widely useful and used by industry as well. And that is obviously peer-reviewed and examined and critiqued by the experts.
Excellent, thanks. Now, I think we had another hand up over there. Have we got a microphone, an extra microphone? If not, you can use mine briefly, because I think it's going to be difficult to pick up the sound.
Hi, I'm Regan from Bristol/Exeter University. Claire, you mentioned that you used to work in detection attribution. I'm thinking about impact attribution, which the UK doesn't have a huge amount of studies for, but tries to say whether anthropogenic climate change has caused for example, X number of extra houses to be flooded. I'm wondering, for the insurance industry, which is obviously quite forward-looking, how useful do you think kind of looking at these past/near past events are in an attribution sense?
For us, this is useful for validation, essentially, to say, does the model do what it's supposed to do looking in the past? From my perspective, again, sitting with my ClimateX hat on, there is a utility for forward-looking things, but there are obviously going to be things we haven't seen before, and we see them already. There is a limitation to the amount of usefulness that a backwards-looking cat model has. What we are trying to develop is something that complements this, that builds on the absolute massive amount of expertise within the cat modeling industry and the absolutely massive stochastic event sets. I mean, these things aren't cheap and aren't small, and they have a lot of value. But there is a step change coming, and the regulator is on it as well in terms of what it is that actually needs to be provided. So I think there's a lot of potential for partnerships there, I think.
I think so, and I think, a lot of in the insurance industry, I think a lot of the steps forward in the kind of climate stress test has really come from this regulatory forcing, and it's coming from the UK. We're globally, I don't think we've seen as many countries. The UK has really been leading that. Europe's catching up, but we're not necessarily seeing as much from America or other regions, for example. But I think if we understand from an insurance perspective, there's never necessarily been a need to think about sort of historical changes and dissect them to that level. Okay, this was due to climate change versus, I don't know, change in population biases, or in terms of the observations. We never really had to need it. We just had to sort of look at, okay, we know some of these records have biases in, we can see them through time, we have to correct for them. But now, with people slicing and dicing and putting it under the microscope, we're saying, okay, how much of, I don't know, the severe thunderstorm activity change that we've seen has been due to climate change? It's a very interesting question. I think that this is where, again, a really good synergy would come. Is it important for insurance right now to know exactly what change to date has been due to climate change versus something else? Maybe not for the day-to-day sort of activities, but of course, the more that the regulators put this under the microscope, then we will have to address these questions.
I mean, not a lot more to add from Caroline, but I think, Caroline, you touched upon when we're looking at the impact of climate change, or can we attribute events to climate change, the exposure has changed so much in that time. And this is one of the biggest things that we have to deal with in sort of when we're looking at historic events, when we're looking at the trend, is the fact that exposure has just increased. But vulnerability has changed as well. My house built 2 years ago we're going to have a massive windstorm now and I'm going to lose it, but should be resistant to pretty much every windstorm because we've designed it that way, and we need to take that into account. But I think where this type of attribution work is really important, I think you mentioned the unseen point, which lay outside the current observations. Our concern is always if there's an event that lies outside the stochastic event set that's generated by the cat models. The insurance industry relies on the fact that every possible event we could see lies in these stochastic event sets. If they don't, then we've not insured against it, essentially. Whether that's due to climate change, whether it's due to exposure changes, whatever the reason is, that type of understanding of these individual events, these key events, that's absolutely critical.
Thanks. Now, shall we see if there's a question on this side of the room? Yeah, I can see a hand here. I'll bring you my microphone.
So we've primarily been talking about weather and climate data from the instrumental record and satellite, presumably. How much do you think paleoclimate data, particularly for the last 1,000 years, is relevant to understanding, A, the completeness of your stochastic data, as well as looking for, high impact, low likelihood events that have nothing to do with climate change per se, they're just internal variability in the system?
Who wants to take that first?
I'll give a stab at it to begin with. I think I'm going to answer by saying that anything that allows us to get a more comprehensive view of the historical record is always beneficial. I think the problem with the paleo record is the fact that we're going to have no exposure information, and so translating what the hazard actually was to so much is different. that translating that hazard to actual risk is always going to be quite difficult. But I will always compliment by saying that, the longer we can extend these records, the more likely we're going to capture these events that we may not have seen before. If we can get that robustly with a sort of low uncertainty, I think that's always going to be my concern with the paleoclimate record, is the uncertainty bars are going to be a bit too large for us to use. But if we can use that information, then yeah, absolutely.
I think just maybe a clarifying question on what kind of timescale for paleoclimate? Are we talking 100,000 years? Oh, right. Sorry. Yeah. Okay. Well, I think certainly, there are certain paleo records of temperature, things that we could look at, maybe look at NAO oscillations and things like that, where we can certainly go back. So, if we're thinking about European extratropical cyclone, for example, the way in which we build our model, it's sort of bootstrapped around a kind of a phase forcing from the NAO. So whilst we have very reliable records for decades, we certainly try and extend back almost hundreds of years, perhaps not thousands of years, but hundreds of years to sort of see what do those NAO cycles look like? Are there anything there that we haven't sort of is beyond or out of the realm of what we've got the more sort of reliable data for? But of course, obviously, the further you go back and some of these proxies, that uncertainty is an important factor, as Adrian mentioned.
Can I add to that? Obviously, yeah, for completeness of event sets, they're obviously quite important. As Adrian has said, with insurance, we're interested in the financial impact, essentially. So what building is there presently? I think it is an interesting sort of statistic to say that this unprecedented event actually isn't unprecedented. We've got evidence of similar things in the paleo record. And to be honest, it is hard to say how we should be folding those in. Even from a scientific perspective, when we're looking forwards in a climate way and saying, how unprecedented is this? Have we seen this sort of thing before?
I think one area as well where paleo is actually incredibly helpful is when looking at coastal flooding. We need to understand what is happening in terms of sea level rise. And when we're looking at trying to constrain or narrow the uncertainty from the ice sheet processes, then if we can take analogues, for instance, from the last interglacial period, a little bit longer than the period you were specifying, but nevertheless, it gives us incredibly useful information in terms of constraining sea level. But it also illustrates the difficulty in finding a suitable analogue. And I think once you start to use the paleo record, there are questions about what aspect of the analogue is appropriate to learn from, and where are the differences. Okay, I'm going to go back to my list for a question now, and then we'll come back and squeeze in either one or two more from the audience. So are there particular perils where you think there's a lack of existing academic or industrial data or research? Who wants to go first?
I can take that one. Yeah, no worries. I mean, I'm not going to say and put my hands up that there's anything where we're complete. That's definitely not true. But I think, to maybe frame this question a little bit more, there are certain perils where, as a community in the insurance sector, we've been modeling them for a lot longer. So tropical cyclone is probably the most mature of the perils, extratropical cyclone, we've been modeling those for a few decades, whereas, things like wildfire and maybe severe thunderstorm, for example, they're a lot more sort of we're in our infancy almost, should we say, with that. I think adding then another frame where you think about what are the perils that are perhaps more complex to model at the scale that we want for insurance. So those really spatially variable, highly variable perils, hail, severe thunderstorm, flood, for example. So you bring all those two kind of perspectives together, and what I say, severe thunderstorm maybe. I put my hand on that one. I think one of the challenges there and the way we've approached it is we're sort of piecing together different types of data, observational data, reanalysis data, looking at, where the atmospheric was conducive to severe thunderstorm activity. And then in the more maybe last 10 years, bringing in sort of radar data as well. So we're using multidisciplinary approaches to try and, patch together our observations, which I think is a great way to do it. But there's also, I think, sort of challenges with that as well.
I completely agree on hail and thunderstorms as being one. I think I like to say that whilst we've been modelling tropical cyclones, European windstorms for a long time, what we still need to understand is the dynamical processes of those real extreme tail events. And I take Colin Manning's recent paper on sting jets within European windstorms, modelling those, understanding the science of those. We have a good understanding of most European windstorms, but really the insurance industry is driven by those extreme tail events. And the more we can understand those processes, it's absolutely key. So it's not just broadly European windstorms, but the damaging events. But I think also it's the interaction between these perils. I think at the moment, the insurance industry broadly considers them independent. We know from Hannah's work, so we were involved in that sort of correlation work, I sat in some calls and made some comments, but Hannah did all the work. But that correlation, those compound multi-hazards, we need to understand those first before we can even begin to talk about modelling them, before we even talk about how we insure them. We need to understand those. And just to throw another one is, subsidence is always a topic of interest.
Great. Claire?
Controversial on the other side, and I'm quite happy with my fires and substance model, but not my TCs model. I'll swap by if you give me your events, I will tell you about our methods. But so I think something that happens a lot in insurance that doesn't happen as much in academia is going from what the weather did to what impact that had. So we're quite happy to say how much it rained, but not where the flood was. And that's something we do a lot in insurance. You run the CAT model, you see where the water ends up. So for the academic perspective, saying, okay, well, I've looked at changes in long-term rainfall and soil moisture. Actually, how does that affect long-term changes in subsidence, for example? So taking that step from I'm interested in the atmosphere to what does it actually mean?
Okay, that's really useful. You just reminded me, Adrian, of something to mention as well. I think within the convective permitting modelling, and I think Colin's paper is a really excellent one, but I think one area that we need to do more of is really unpick the structural uncertainty in the convective permitting models, because at the moment we're tending to use individual models or perturbations of those models, but not compare the structural differences. And there are hints in some of the runs from EUCP of quite different responses when you look actually at the detail of the storm. And I don't know if that will carry through to the sting jet or not, but might be an interesting one to pick up. Okay, let's come back to the audience. Have we got any more hands up? Either side this time. I think it's okay to have two goes. I'm going to give you the microphone this time as well.
I think this is partly for you, Jason, as well. I sometimes feel like there's a lot of belief in model capability. And I think when we're coming to compound risk or the sort of extreme events that occur because something is slightly different, we're moving more into the Earth systems. So understanding the sort of land surface atmosphere feedback systems, which climate models aren't amazing at, because resolution issues, but also because it's limited resources and you prioritize key drivers. So this is something I think is quite important as well, is that we don't get too locked in just looking at the model output, but the observational data, making sure that we actually, are they accurately represented? Because otherwise you're not going to capture change. Even if it spits out data, but might be meaningless.
I'm going to ask that to all of the panel. Caroline, do you want to start this time? I'm also going to bring in Erica to comment on this question because I know she has a particular perspective. So if you want to go first, Caroline?
So maybe, just to make sure I understand the question right, you're sort of saying sort of the climate models and what's coming out of the atmosphere, but it's important that the rest of it, almost translating those signals through to the hazard itself and the intensity measures that are then going to feed into, the damage estimation. Is that what you're saying, if that's important?
It's when you start to look at things like fire, soil moisture, vegetation dynamics, and all those other aspects start to be important. We're assuming that models actually do these things well.
So the model is not the real world. We know that. Yep. Sometimes the model looks like the real world for the wrong reasons as well, and sometimes it doesn't look like the real world. Given that, how do we still get useful information from it and not overuse or abuse the model, pushing beyond what it can tell us?
Well, I think that this is a very good point, and when we're sort of building CAT models, we are on every component that we're building them from. We're going to try and do sort of validation along the way. Is this making sense? Is there, what would we do if we change this assumption or that assumption, and what was the impact be on that sort of thing? So we're trying to look at that from almost like a component based up. But then equally, I think from our perspectives as well, like looking what's happened from a top-down perspective. So once we built the model, whether it be the whole hazard component, does that make sense? Does that compare to what we've, how does that validate with what we have seen in history to the best we can? Of course, there's things that we haven't seen. Perhaps sort of saying, what if this was just changed, or this event had made landfall a slightly different place, or things like that. So I mean, I don't want to sort of get into the counterfactuals. I feel some people maybe later today will get into that sort of side of things. But I think when we are building the output, we are constantly asking ourselves, does this make physical sense? Especially if we're using some of the AI deep learning data as well. It's like, what are we coming out with? Does that make physical sense? Are we breaking any laws of physics here? And then when we can sort of combine it with all the components part, is it still making sense in that sense? But it's a really good question. I think very tough to answer. But
so obviously all models are wrong, but some models are useful. And I know that there's an absolute amount of work that goes into understanding how good the climate models are and why, or why they're not and where they're not. For the sort of dealing with the industry and delivering this data and eventually selling this data and someone making a decision based off it, having that understanding of what the model does well and what it doesn't and why is really important, and communicating that and folding it into your decision at the end of the day is something that I really hope that our sort of decision makers who use our data do. Because you can say, well, to the best of our understanding, with these caveats, this is what we believe the risk is, or this is what we believe might happen. However, there are these caveats as well, and if you get a particularly wet winter, that will completely change your risk for fire in the summer or things like that. Again, it's an area of research, and I don't think we have a complete answer to that just yet.
I completely agree with your comments and the comments we made on the panel, and that's part of what we do is we stress test all of the CAT models we use, all of the data we get in. Obviously, there are issues with that. And just to highlight, there are issues with our loss data as well that we get in. That's not comprehensive. And trying to disentangle what was due to flood, what was due to wind when the two events were very close or when they're months apart. All of this data needs cleaning. All of this data needs interpreting. And it's up to as long as we're transparent in the methodology we use to interpret that data, that's absolutely the key, because then we can have these discussions. So Caroline and I, well, not just Caroline and I, but our teams have these discussions around the methodologies. We're very transparent so that we can stress test these models, really go into understanding what are causing the differences. And then we as a broker go to all of the other modeling companies and we use all of the different observation data we can get our hands on. Whilst accepting that there are limitations, nothing's perfect, but we've got to build as good a picture as we can, as long as we do that in a sort of transparent method, but also getting that feedback from academia, who's looking at it from yet a different angle, and using the entire academic community to sort of get that voice. So,
thanks. Erica, do you want a chance to come in on this? Don't want to put you on the spot, but today's all about surprises. That's what insurance is.
Great, thanks, Jason. So I suppose my perspective on this is that we shouldn't be looking to validate models in a binary way. We should be saying we want to escape from model land and make statements based on model-derived information which are about the real world. So in order to make a statement which is about the real world, we have our model information, but to get out of that model land, we have to make an expert judgment from outside of model land about the quality of the model. And so that has to be a quantitative judgment. We have to actually say and be willing to step forward and make a judgment which will feel subjective, and it will certainly be something that people can argue about, and it will be based on incomplete data. But in order to make a quantitative statement about the real world, we must make that quantitative expert judgment about the relationship between model land and real world. So that's, that is difficult, it is challenging. But I think that there are structured and sensible ways of going about doing that. And then, that introduces a whole load of other discussions about exactly how we do that and exactly what format those judgments should take and how we should discuss them and disagree between each other about what those judgments are.
Thanks, Erica. Okay, I think we've got time for one more question. I'm going to take one for this one. Can you think of examples where academic science has pulled through into industry? And ideally, an example where it's worked, and perhaps an example where it hasn't worked so well, or the lessons we might take from that. Shall we start at Claire's end this time and work back?
Examples where it's worked well. Our storm scientist who's looking at North Atlantic storms and tropical cyclones did a PhD in using forecast model ensembles to look at climate risk, especially from the attribution perspective. And we have taken that PhD and applied it to look at North Atlantic storms and tropical cyclones now. It was originally developed for heat waves and from the attribution perspective, so that was really good, using forecast models to look at climate change. One that's been quite challenging is hydraulic flood models and running them everywhere in the world all at once. Hydraulic flood models are often designed to run on your favorite little river basin and to be running great detail with great knowledge of what's going on the ground. But then if you want to do this somewhere in the developing world where the data you've got isn't as good quality as you would like, it suddenly becomes very, very hard.
No worries. I think one specific for atmospheric side is towards this like deep learning that I mentioned earlier. So we actually sponsored a guy in the US to do his PhD and sort of learning and starting these techniques, learning how to use deep learning to sort of bias correct some of the GCM outputs and actually then start to downscale on that. And that's something that's sort of been continued. He now works for us and he's sort of heading up this team. So I think that's been a great success. The other one that I think that Adrian touched on earlier, maybe we can come back to this one, about sort of compound events, correlation between perils in a given region. So, I'll preface this that the work that Hannah's done sort of recently, sort of with some kind of showing some material impacts between UK sort of flood and extratropical cyclone losses. Preface to that, maybe a few years before, sort of Lloyd's of London worked with the Met Office on a wider study on sort of a global basis, looking at sort of teleconnections, characterising those sort of around the world for a wide degree of different sort of perils. And I think, I remember going to EGU and seeing from a hazard perspective, sort of a really nice matrix of these correlations sort of set out. And then it was sort of taken and ingested by the team at Lloyd's. There were some methods there. There was some processing of that to work out whether actually the assumption of events being independent, whether Japan typhoon and US hurricane would be independent. The conclusion was very much they are still independent. So I think the conclusion of that paper at that time was, okay, maybe there's some regional differences, but globally. And I think that I'm not sure that sort of sat naturally with everybody in the community. I think our gut instinct is actually, I'm not sure that was really true. And I think it's been great to see almost some of the regional work being picked up and sort of focused on and actually being sort of shown to sort of be material. So I think that's an example of where we've sort of seen some progression on a kind of similar topic with some maybe sort of more successful outcomes on a regional basis. Sorry if I pitched your idea.
Partly, but it's fine. And I think Jason's already pinched one of my ideas anyway by presenting it. But for me, that's a classic example. And I think one thing I want to preface this is by one of the things that we do in our team is develop the Aon view of risk. Now, that's not a full CAT model. It's a view to be able to benchmark those CAT models against and benchmark sort of the views of our clients. Now, if a client comes to us and asks us about compound hazards, we're not able to use a CAT model, so we need to be able to develop our own view of risk. And this is part of the work that, Hannah's work will be able to pull through. Now, okay, we're not going to be able to sort of put that into an insurance contract at this stage or be able to insure against it potentially, arguably, at this stage, but we're developing that view. And I think that can then be more broadly about all of the academic papers that we read and that we pull through. I think my favorite is when somebody within Aon discussed a paper and I was a co-author on it. Oh, it's very nice to feel that way. But also some of the limitations are that at the moment is developing a view of risk. What does that mean to sort of how we actually undertake insurance or how do we write insurance? I think we're still sort of a few years away from that. But again, picking up on Caroline's sort of compound hazards, multi-hazards, multi-risks, it's that I think what we'll find is then when we get a better understanding of those, we're actually going to be able to label quite a few events with that description. And so it will be really interesting to see how our view changes as we progress.
Excellent. Christoph, are we out of time now?
2 minutes for a super quick question.
2 minutes. In that case, I'm going to use the 2 minutes to offer each person a few short remarks to sum up. Now, I think Claire and Adrian have started lots of times recently. So, Caroline, do you want to go first this time?
Yeah, keep me honest on the time. I mean, I think it's great that these events are happening. I think we're talking about academia, bridging that gap. What I would just encourage people to do is do more of that, actually get down to the technicalities. And again, I just want to do a shout out to an event I worked on recently where we were working with a bunch of researchers from the National Centre for Earth Observation, and we did like a Dragon's Den style pitching session. It was very intense. Each sort of researcher had about 4 minutes to sort of show their research to us, and we kind of gave some comments and thoughts, and it was an intense, but it got people talking. So some of my fellow dragons are in the audience here. It was a great experience. I think just get talking. Find those opportunities to do that.
One comment I hear a lot from academics is that it's along the lines of, I had no idea that my research was being used in industry and that there even was regulation around climate change and the finance sector. But there's a lot of research that has a lot to offer to the industry in academia, but so many academics don't even know that this is a thing that they can do. So making those links would be absolutely great. I think there's so much potential here that we aren't making use of.
I think I'm always interested in research that challenges our current view. We're not looking for something that backs up our current view or tries to emulate what the CAT models do, but what we need to be able to do is benchmark and challenge those models so that these events that we may not have seen, or so that these assumptions that we're making in the industry, we're able to challenge. And so it really is sort of thought-provoking, blue sky, but how does that apply to us, challenge us in our thinking?
Excellent. Can we thank our panel? I think they've had some excellent responses. Christoph, back to you.
Can we also thank Jason for an excellent panel chairing and roving around the room? So thanks everyone. This was the first part of our of the session. So we heard about let's say the climate science point of view is how we started, and then talked about how this can be translated into decision making. A lot of food for thought, a lot of ideas, a call to action to do more talking. So you have half an hour to speak to each other, answer some of the questions that were raised. On coffee this time, and afterwards you can talk over a drink. So come back in half an hour, and see you there for the second part of the event. Thank you.